I welcome you to the second session of percentage. In this session, we will take a look at the concept of percentage increase or decrease. Now, what happens if a number is increased by some percentage, say R%? If a number is increased by R%, then the number becomes 100 plus R upon 100 times itself, which is also equal to 100 plus R% of itself. So if a number is increased by R%, then either it will become 100 plus R by 100 times itself, and which is also equal to 100 plus R% of itself. Let us take an example. If a number P is increased by 20%, then P becomes 100 plus 20 by 100 times P, that is equal to 1.2 P. Similarly, it could also be called as 100 plus 20% of itself, that is equal to 120% of P, which implies that 120% of P is equal to 1.2 P. So if a number P is increased by 20%, we can call the new number to be 120% of P, or we can say it is equal to 1.2 P. Both are one and the same thing. Let us take a few examples. P increased 30% is equal to 130% of P, or it is equal to 1.3 P. P increased by 40% is equal to 140% of P, which is equal to 1.4 P. P increased by 50% is equal to 150% of P, which is equal to 1.5 P. Similarly, P decreased by 30% is equal to 70% of P, which is equal to 0.7 P. P decreased by 40% is equal to 60% of P, which is equal to 0.6 P. And P decreased by 50% is equal to 50% of P, which is equal to 0.5 P. Now the new value of the number after some percentage increase and decrease, should be internalized by all of you who are appearing for any competitive exams. This should be almost a digital process. 30% increase means 1.3 P or 130% of P. This understanding has to be almost immediate. And I recommend that those of you who are not comfortable with this, do a lot of practice on this before you proceed with this video. Say a number is increased by 20% becomes 144. What was the original number? We've seen just now that when a number is increased by 20%, it becomes 120% of itself or 1.2 times itself. So what do we have? If n is a number and when n is increased by 20%, it becomes 120% of n, that is equal to 1.2 n. And what is the value of 1.2 n? The value of 1.2 n given in the question is 144. So n is equal to 120. Let us take another similar question. A number is decreased by 30%. It becomes 112. What was the original number? So when a number is decreased by 30%, it becomes 70% of itself. So n decreased by 30% is 70% of n or 0.7 n. So what do you equate here? 0.7 n is equal to 112 and n is equal to 160. So what is successive increase or decrease? When we find two or more increase or decrease percentages, then we call it to be successive percentage increase or decrease. So if a number P decreases by 20% and then decreases by 30%, so it decreases twice. So this kind of decrease is a successive percentage decrease. Whenever a number decreases by 20%, it will be 100 minus 20% of itself. And then when it decreases by 30%, it becomes 100 minus 30% of itself. So therefore, a number that decreases once by 20% and then by 30% becomes 100 minus 20 into 100 minus 30% of itself, which is equal to 80% of 70% of P. And then you can simplify this. If this were a successive increase, number increased by 20% and then by 30%, then it would be 100 plus 20% into 100 plus 30% of P. So is equal to 100 plus 20 into 100 plus 30% of P, which is equal to 120% of 130% of P. And now you can once again simplify this. So you can calculate questions of successive increase or successive decrease in this way very easily. Let us see another method of calculating successive increase or successive decrease. Now mind you, the method that I just now shared with you is a universal method. If there are more number of increases or more number of decreases, then you can simply keep on adding those brackets. But here is a very quick method to calculate successive increase or decrease if there are only two successive increases or decreases, or maybe one increase and one decrease. But there are only two percentages in question. For example, if there is a successive increase or decrease only two times by P% and second time by Q%, then overall the increase or decrease shall be given by P plus Q plus PQ divided by 100. Please note that if there is a decrease, we need to put a negative value before the numeric value of the same. For example, if one of them is a percentage decrease, say 20% decrease, instead of placing that as only 20, place it everywhere as minus 20. So if P is equal to minus 20, everywhere wherever P appears in the above formula, place minus 20. Let us solve one simple question. If a value is increased by 20% twice, then what is the net percentage increase in the value? If the number is P, then the net increase is given by 120% of 120% of P, which is equal to 1.2 into 1.2 P, which is equal to 1.44 P. And you would recognize immediately that 1.44 P means it has increased to 1.44 into 100% of P. So it has become 144% of P. And 144% of P is nothing but 44% increase. Now what we have done here is we have changed this particular percentage into a decimal here, and here we have changed the decimal back to a percentage by multiplying it by 100. Let us solve it using the formula. If a value is increased by 20% twice, then what is the net percentage increase in that value? Let us say the number is y. Then the overall increase is given by P plus Q plus PQ by 100. And let us place the value of P and Q. P is 20 and Q is also 20. So 20 plus 20 plus 20 into 20 divided by 100, that is equal to a 44% increase. It is the same answer that we got previously. Let us take a look at another question. If a value is increased by 20% once and then decreased by 10%, then what is the net percentage increase or decrease in that value? Again, the overall increase or decrease is given by P plus Q plus PQ by 100. P is equal to 20%, that is an increase. Q, that is a decrease, is indicated by minus 10%. Now wherever there is a Q, put minus 10 over there. So we have 20 plus minus of 10 plus 20 into minus 10 divided by 100, P into Q by 100. And if you solve this, you will get 10 minus 2, which is equal to 8%. So you saw that this particular formula is applicable only when two percentages are given. For more than two percentages, please do not use this formula. Let us take a look at another question. Population of a town increases by 20% in the first year, 30% in the second year, and reduces by 10% in the third year. If the population at the end of the third year is 1404, what was the initial population? Now can we apply our formula P plus Q plus PQ by 100? The answer here is no, because there are more than two percentages. Here we have two increase percentages and one percentage decrease. And therefore we have to apply the fundamental formula, the fundamental rule of solving such questions. So if the population in the initial year is P, then population after third years or population after 3 years can be stated as 120% of 130% of 90% of P. And 90% is because in the third year there is a 10% reduction. So 120% of 130% of 90% of P is equal to the population after 3 years, that is 1404, which results into 1.2 into 1.3 into 0.9 P is equal to 1404, and 1.44p is equal to 1404, which yields p as 1000. So we saw that if percentages are more than 2, then our formula cannot apply. We have to solve that question by basic method. With this, we come to an end of this session of percentage. If you have any feedback or any query, feel free to write to us at studentservices@pfindia.com. Thank you.